Today, we're going to dive into something really important, an idea from Amit Raghavanshi. It's about what really separates a good engineer from a truly great one. And here's a hint. It's not about the tools you know. It's all about how you think.
Okay, let's just list a few. Kubernetes, Kafka, Redis, Terraform, right? These are the heavy hitters, the titans of modern engineering. We spend years trying to master them, digging into their APIs, their configs. We feel like, yeah, I know these tools. Or do we?
So, if we're all getting so good at these tools, why do systems still break? I mean, why do projects that start with the best intentions end up spiraling into this mess of complexity? Well, the answer comes down to a really, really important distinction. And here it is. This is the heart of the matter. Knowing a tool is not the same as using it well. That gap, that space between knowing and using well, that's pretty much the entire journey from being a junior engineer to a senior one. All right, so let's actually break this down. Let's look at these two different worlds. The world of just knowing a tool versus the world of using it well. So, knowing a tool, let's call that surface competence. This is all about the features, right? The config files, the basic what does this button do kind of stuff. And look, that's your starting point. It's absolutely the foundation. You have to have it, but it's just not the whole picture, not even close. Just look at the difference here. On one side, you've got knowing a tool. That's all about the features, right? The APIs, the benchmarks. But then you look at the other side, using it well, and suddenly the conversation changes completely. Now we're talking about trade-offs, failure modes, what it actually costs to run this thing. We're moving from just features to the all-important context. And you can really see this shift in the kind of questions people ask. You start out your career asking, okay, what does this tool do? How do I set it up? But as you get more experience, the questions get a lot more interesting. You start asking, when is this a bad idea? When should we absolutely not use this? What's the first thing that's going to break? See that? It's the difference between just collecting knowledge and actually applying wisdom. Okay, this might feel a little abstract, so let's make it super concrete. We'll use a tool probably everyone here knows, Redis. So here's the classic surface level take. You hear this all the time. Redis is an in-memory cache. It's fast, we should use it. Now, that's not technically wrong, but oh man, is it incomplete. Dangerously incomplete. It's like you see one feature, speed, and you jump straight to a conclusion. You're basically treating the tool like it's some kind of magic wand. Now, let's compare that to how an architect thinks. It's a whole different ballgame. They're thinking about the specific use case, like, okay, this is for read-heavy data and we need TTLs. They're already thinking about what could go wrong, like cache stampedes, and how to prevent them with things like jitter. They have a plan for failure. If the cache goes down, we fall back to the database. And maybe the most important thing of all, they never forget that Redis is not the source of truth. It's the exact same tool, right? Redis is still Redis. But the level of thinking, the awareness of the entire system around it, it's just a completely different universe.
And all of this leads us to what I think is a fundamental rule of good system design.
Here's the first part. Tools don't make systems scalable. Just let that sit for a second. We fall into this trap all the time, right? We think, oh, if we just use Kubernetes, our system will magically be scalable. But that is such a dangerous assumption to make. So what does decisions do? The success of your system, its scalability, its reliability, it all comes down to the thousands of little decisions you make. The tool is just how you execute those decisions. And here's the real kicker. Tools are just amplifiers. They amplify your decisions, whether they're good or bad. So if you make a brilliant architectural decision, a powerful tool will let you do amazing things. But if you make a bad decision, that same powerful tool will just help you fail bigger and faster. And that's why this is so true. A bad decision with a powerful tool, well, that just fails faster. But a good decision, even with a simpler tool, that's what wins in the long run. The quality of your thinking will always, always be more important than the shininess of your tools. Okay, so the big question is, how do we actually do this? How do we make that leap from just knowledge to real wisdom? I love this framing because it just says it all. Junior engineers collect tools. It's like they're trying to fill up their resume with logos. But senior engineers, They collect trade-offs. So my advice is to stop worrying so much about the list of tools on your resume. Instead, focus on building this mental library of trade-offs, of failure patterns, of understanding the why behind decisions. So here's the path. It's really just a simple shift in your thinking. Step 1. Stop asking, what tool should I use? Instead, you're going to start asking, what problem am I really trying to solve here? And then, the crucial follow-up, and what am I trading away to solve it? Seriously, make this question your mantra. It doesn't matter if you're picking a database, a message queue, a whole new framework, always, always come back to that question. What problem am I solving, and what am I trading away? Because that shift, from thinking about tools first to thinking about problems first, well, that's what turns a good engineer into a great architect.